My name is Dusty, and I will provide an overview on the following paper called TiYunZong, an exploit chain to remotely root any Android device by author Guang Gong. First, the author explained the two different ways to remotely attack a smartphone. One of the ways is to attack through the internet, in which it specifically targets something like browsers, email, iMessages, and etc. It is more destructive, but it also needs some sort of user interaction, like clicking on a malicious link. The second ways to attack a smartphone is through adjacent network, and this primarily targets something like near-field communication, MFC, the Bluetooth, or Wi-Fi. It is much easier to launch. However, the exploitation that he used is actually an exploit chain that involves attacking through the internet. This is a figure from the author's paper, and it shows the exploit chain that he found and developed through his research. And as you can see, there's about 2 Chrome exploitations and 1 GPU driver exploitations. So in order to get to the destination of rooting the Android phone remotely, you have to follow the chain. As first you have to break through the first layer, then the second layer, and then to the last layer. So his exploitation is actually leading one to the other, is providing some sort of path in order to achieve the goal. So to exploit to explain the exploit chain a little bit, the first layer is the OBSS bug that helps it move on to the second layer, in which it can trigger the first layer called a module call to trigger the second bug, and from this build an exploit to compromise the media component, in which when the media components compromise into a domain untrusted app, it can then gain access to the GPU driver. And then the third exploit is to actually deceive the GPU driver and overriding it. So the first vulnerability, the author called it the RCE vulnerability, which located inside a JavaScript interface v8, and it's on the macro called getDerivedMap. And basically on line 6, the problem is that it's trying to get some sort of map, like a phototype or an initial map of the new target, which is like the argument in this case. So what is the problem with this cause is that it doesn't check if the new target even contain a phototype or an initial map. It's just directly access to it. And here lays the problem, because what if there is some sort of functions that you called, for example, like a proxy function. In this case, he discovered that it doesn't have any prototype slots. So what happens if the new target is a proxy function that doesn't have any prototype slot? Well, if you call the macro getDerivedMap, and you add the proxy function as the argument, and when it tries to get the field prototype or initial map, it will trigger an exception that is an out-of-bound access, because the proxy function does not have an outer prototype slots. So that is one of the vulnerability that he found that can be used to exploit. So on the surface level, what he does with the exploitation is that he's using the proxy functions and adding different maps into it, and also creating a malformed type array in which he could easily do an arbitrary read and write, and then from there enable the module JavaScript bindings and exploit it. So the second level of vulnerability, called an EOP vulnerability, would involve the CDM or contain description modules in Chrome. And what it does is what happens is that every time you initialize it, there isn't a restriction on the number of initialization. And every time you initialize something, different IDs will provide for it. However, when you removed the CDM service, only one of these IDs is being removed and unregistered. The other ID will be mapped onto a dangling pointer. And from this, you can trigger a function called getCDM context reference, which will then trigger the bug. And then you can get the Mojo CDM service to reconfigure and run a different process. However, on Android, that is unnecessary, as the default is to run the GPU process, which is exactly what the author wants to achieve, is to get into the GPU. So how did he exploit the EOP vulnerability? It's basically he employed the basic return to libc techniques in order to execute a shell command from there, and that's how he able to get access to the GPU. The last exploit on the chain is the root vulnerabilities, and this is involving the kernel itself. There's a thing called read pointer that's stored in the scratch memories, and this is where it goes wrong, is that for some reason the scratch memory is set to writable by normal GPU command processors in the following function. Most of the Android's phone use the Adreno GPU system, so in the Adreno ring buffer probes functions on line 9, it was set to writable. And what happened is that you can overwrite the command processor instructions and inject malicious commands into the ring buffer for it to execute, which is not a good thing. So how did he actually achieve the result that he wants? Is basically you have to modify this or the read pointer in the scratch memory by moving it and creating fake free space, which is not actually fake. It is trying to trick the GPU into thinking there is free space above it. And then he filled in the middle and then execute from the middle with a bunch of knobs or CP knobs, basically, kind of like a knob sled there. So in conclusion, what it is sort of research important is that it provide insights into a lot of technology that we can improve upon. And for why use technology like the smartphones, you really doesn't want your data to get around there in just 3 different steps. Basically, it required the author 3 different steps and 3 different exploitation in order to completely root your Android phone and extract your information from the root phone. And it is very dangerous. And for this type of things, how do we prevent against it? Is to basically gain knowledge about it and improve ourselves from there. A lot of these codes that was exploited or found by the author was vulnerabilities, takes only like 1 line. Most of them are just something that people wrongly write in, or just something that is, wasn't really careful of, like checking the conditions or something like that, which is pretty insane that the author is able to find these small vulnerability and exploit it, and actually creating something that is, and demonstrating to us something very problematic, such as remote hacking is very much possible. And in conclusion, the author says that the Google Pixel phone is one of the most secure smartphones, and he's been trying to find ways to break it and have been very much successful because it's have latest technology, latest mitigation to these type of exploitations. Finally, here's the reference to his papers and presentation. Thank you very much for watching.